Dear students, in this video lecture we will be seeing the another important category of clustering, that is the density based clustering, and we will subsequently see the algorithm and the issues related to DBScan and its strengths and weaknesses. So the density based clustering locates the regions of high density that are separated from one another by regions of low density. DBScan is a simple and effective density based clustering algorithm. There are various approaches for defining the density, but here we will focus on the center based approach. In center based approach, the density is estimated for a particular point in the data set by counting the number of points within a specified radius, that is the EPS of that point. So what we will do means, in order to keep the notion of the density of points, we will say that if the points falls beyond this EPS radius, then it will be taken into consideration, otherwise it will not be taken into consideration. That is what we are going to do in a center based approach, where we count the number of points within a specified radius of that point. This includes the point itself also. So this technique is graphically illustrated in the figure, where a number of points within a radius of EPS of the point A is 7, including A itself. Suppose if you take a center based density, here you can count the number of points within this EPS radius, that is 1, 2, 3, 4, 5, 6 and 7, that is including the point A. This method is simple to implement, but the density of any point will depend on the specified radius. If you are going to increase the radius, more number of points can come, or it depends upon how the data points are exactly spread. It doesn't always mean that increasing the radius will get the more points. For instance, if the radius is large enough, then all the points will have a density of m, the number of points in the data set. Let us see the classification of the points according to the center based density. Center based approach to density allows us to classify a point as following: that is, in the interior of a dense region, that is a core point; on the edge of a dense region, a border point; in a sparsely occupied region, a noise or background point. So this core, border and noise points can be depicted in the figure as follows. So here you can see that core point, which is well inside a cluster, a border point which is on the edge of the cluster, and the noise point which is outside or outside the edge of the cluster. Let us see each one of these individually, then we will go to the algorithm. Core points, these points are in the interior of a density based cluster. A point is a core point if the number of points within a given neighborhood around the point, as determined by the distance function and a user specified distance parameter EPS, exceeds a certain threshold, which is denoted by the min points over here. So if you see the figure 8.21, point A is a core point. Reason: the indicated radius EPS, the min points is less than or equal to 7. That is, you are having a greater value than a threshold called as the min points, 1, 2, 3, 4, 5, 6, 7. That's why it is a core point. Next we will see what do you mean by a border point. A border point is not a core point, but falls within the neighborhood of a core point. So in the figure 8.21, point B will be a border point, since it is a neighborhood of a core point. Noise points. A noise point is any point that is neither a core point nor a border point. So in the figure 6.21. Point C is a noise point. Neither it is a core point nor it is a neighborhood of core point. That's why C is considered as the noise point. So we will stop the introduction to DBScan over here. In the next lecture we will see the DBScan algorithm and the time and space complexity of that, and the further issues and strengths and weaknesses we will discuss in the future course. Thank you.